In this video, we're going to use related rates to solve problems involving volume. It says the volume of a cube increases at a rate of 3 meters cubed per second. Find the rate at which the side of the cube changes when its length is 7 meters. So the first thing we need to understand is that for a cube, all the sides on a cube are the same, and we've got 3 sides. So the volume equation for a cube would be V equals, I'm going to call it x cubed. And so you have this cube out here. I'll do my best to draw a cube. Looks like so. And you've got an x value here, an x value here, and an x value here. So you've got, this would be a width, this would be a length, and this would be a height. So volume equals x cubed. Now they're asking us to find dx over dt. So they want dx over dt, the change in the x with respect to time. And they give us dv over dt, which is 3 meters cubed per second. So anytime they start talking about rates, we know the rates are derivatives. So the rate at which the side of the cube changes when its length is 7 meters. So we're looking for the rate that x is changing. And then we're also looking for they give us the volume of a cube increases. So that's a rate that the volume is increasing at of 3 meters cubed per second. So let's take the derivative of this equation with respect to time. And we're always doing with respect to time for related rates problems because each of these quantities are changing over a period of time. So derivative of v with respect to t would be dv over dt, which is equal to d over dt of x cubed. Well, if I take the derivative, well, let's write it out first, d over dt of x cubed. If I take the derivative of x with respect to t, I'm using implicit differentiation. So I'm going to go ahead and say that that is 3x squared when I take the derivative of it, but I have to offset that by saying dx over dt because I'm taking the derivative with respect to t and not x. Now I can go ahead and plug in the things I know. They said they wanted to know what dx over dt is. I'm going to say at x equals 7 meters. So we're going to go ahead and plug in 7 and our value here, which is 3 meters cubed per second, equals 3 times 7 squared times dx over dt. Well, if we go ahead and multiply this out, we get 3 meters cubed per second equals, we're going to get 49 times 3, which is 147. And that'd be 147, that'd be meters squared. So if we divide that across on each side, that would simplify to being 1 over 49 meters per second is what dx over dt is. So we could say that the change, or the rate at which the side of the cube changes when its length is 7 meters, would be 1 over 49 meters per second.